Okay, so hopefully everyone can hear me all right. It's 11:02. We'll probably get started, otherwise we'll not be able to finish on time. It is 1 hour, so there's only a lot that we can do. So, I will try and go through as many concepts as possible. I thought I had time for questions, but I don't really have time to go through the questions just now. So the questions, topical questions on acid, bases, and salts were already posted on the Classroom, Google Classroom under the assignments. So you can go through them and feel free to ask any questions that you try. Of course, the idea being that you have to try. If you don't try, then you're not going to improve at all. Your examination is most likely in 2022, so none of you are doing the new syllabus, so you're still on the old syllabus. Like I told you many times, the syllabus has changed drastically. So if you mess up this November, the next time you sit for your exam, you will be sitting for the new syllabus where everything has changed. So there's not much room for you to mess up at all. I went through redox reaction as well as redox in previous classes. I didn't go through reversible reaction because that one is best done when it's face-to-face next time, when I see you probably sometime next month, to be honest, when it's face-to-face, okay? So without further ado, let's get started on this chemistry and uses of acids, bases, and salts. So in these kind of tutorials, I will go through the theory, but anytime you have questions, then feel free to just rest up your questions. Otherwise, you're not going to learn very much from me at all. So it looks like there aren't a lot of people. Yeah, there's Afrika, Irene, and Azwani. So only 3 people. I don't know. Maybe they're late. They can just watch the recorded sessions. Don't really know. Okay. Anyway, so characteristic properties of acids and bases. So in terms of the meanings of acids and alkalis, so we know that acid is a proton donor. We call this H+, meaning it's a proton donor. We know alkali is in terms of it's a proton acceptor. But why? Why in the world can it accept protons? Because it has OH- in solutions. These are about what they contain or what they produce in aqueous solutions and their effects on universal indicator paper. So when I went through this with the other class, I went through these things, which you will have to reproduce on your own in order for you to fully understand what is going on. So alkalis and acids, or bases and alkalis together with acids. So this one contains hydrogen ions. We pronounce this as H+ ions, or you can call this as protons in the context of acid and bases. This one contains OH- ions. Okay, it can contain or it can dissociate into H+ and OH- in water. So this is in solution. In solution, what do you have? So an acid is fully defined as a substance that dissolves in water. So in aqueous solutions, as it dissolves in water, what does it give you? It gives or it produces H+ ions. Whereas when you have a base, you have a substance that dissolves in water, and then you will get this thing called hydroxide ion, which is OH- ions. The name is not called proton, the name is called hydroxide ions. Having done that, if you have something called pH meter is a sensor. It's a sensor that will, once you dip it into the solution, it will tell you the pH of the solutions. The pH of alkalis or bases is above 7, whereas the pH of acid is below 7. You can use things like litmus. You can use things like litmus, where this one, the red litmus will turn blue. This is the test for alkali or bases, whereas for acids, the blue litmus will turn red. But that is not very helpful, especially if you want to know roughly, whether it's a strong or weak acid, strong or weak base. That is where universal indicator comes in. So we have this thing, strong versus weak. So if you have pH 7, which is neutral pH, so this is what you call neutral pH, then pH above 7 can be around pH, pH 8 to 10, for instance. This is what you call a weak base. Whereas when you have pH, 4 to 6, that is around a weak acid regime. Whereas you can have the more extreme side, such as pH 13 to 14, that one will be your strong. Don't know why I didn't write that properly. This is your strong base. Whereas you have pH 1 to 2, this is your strong acid regime. So universal indicator can tell you the difference between strong versus weak acid. It can tell you the difference between strong versus weak base because it will have specific color changes. And you have to specify. The question will always say, describe how you can use universal indicator to tell the difference between this strong acid and weak acid. So it's not just you can use universal indicator, but also the color changes. In the weak acid, you will have orange, yellow color for universal indicator. You will have red color for the strong acid. Whereas the weak base, it will show a blue color and you will have a purple color when it's a strong base. These are different color changes, whether it's strong acid, strong base, or strong weak acid, weak base. Now, based on this, they ask you to define. I forgot that in universal indicator, pH 7 is supposed to be green. pH 7 is green color for your universal indicator. Okay, it's not litmus, it's just universal indicator. If you are asked to define what is a strong acid and what is a weak acid, quite a common thing they are to ask you. Yeah, so a strong acid fully dissociates, or you can say fully ionizes or dissociate, whichever word you like. It's an acid, so it dissociates into H plus ions in water. Whereas when you have a weak acid, you only have partial dissociation. So partially dissociates or partially ionizes into H plus ions in solution. Same thing goes for base. It's something to do with partial dissociation or partial ionization. But bases is to do with ionization into hydroxide ions. And of course, strong base, again, fully dissociates or fully ionizes into OH minus ions. Very, very important, the extent of dissociation, of which you can use universal indicator to indicate to you based on the color changes. Now, what else do they like to ask you? Show using equation. Show or define by using an equation to show what is going on. HCl, full arrow, going to H plus and Cl minus. H2SO4, full arrow, going to 2H plus. And this is your sulfate and ions, is SO4 2 minus after you dissociate to 2H plus. When you have a strong base, you'll be looking at NaOH going to Na plus plus OH minus, something like KOH going to K plus and OH minus. Of course, you are dissociating to ions, so your charges on the right have to balance out the total charge on the left. In this case, plus 1 times 2 is plus 2, minus 2 times 1 is minus 2. Overall, no charge there on the left and on the right overall. The problem is this partial dissociation. A lot of students forget that they have to show, such as Etanoic Acid, CH3CO2H is what we call Etanoic Acid. I found out from the other class that, of course, some people are from the express stream. So that means you might not have completely covered your syllabus yet because there's only so much you could do in 1 year and a half, I guess. So you will come across carboxylic acid in the final bit of your O-level syllabus, but you will come across ethanoic acid in your acid and bases topic regardless. When you dissociate to give you your H plus, that means your H plus is already gone, separated. Whatever is left behind has one lesser H, and you must have a minus 1 charge there. This is the key component. This is called reversible. Reversible means the left will go on to produce the right, but then some of the right-hand side will go back to form back the left-hand side. That's why it's called partial dissociation, because not everything gets dissociated, as some of them recombine to give you back your molecule. The ammonia, example of these would be ammonia. Ammonia is NH3, and then you don't see any oxygen in ammonia. But then definition of a base, a substance that dissolves in water. So ammonia on its own does not have hydroxide, but it ionizes in water partially. So I need to show NH3 plus H2O. What happened then is I will get OH minus, and then I will get NH4 plus OH minus. So this is a key equation. If you see what happened to the NH3 is it accepts the H plus from the H2O, and the H2O donates the H plus. So whatever the accept the H plus is because you have OH minus, and then you dissociate partially in water to give you OH minus. So reversible or partially ionizes into OH minus ion. That's why it's a weak base, which you can tell and compare with strong base by looking at the color changes, specify the color. in weak versus strong base using universal indicator. That is pretty much it stated in the syllabus. Use universal indicator, their effects, plural there. And then how to test hydrogen ion concentrations, relative acidity. So this means strong versus weak using universal indicator. Describe, so you need to use color changes. So you know that in a weak acid, it will be orange-yellow color, whereas in a strong acid, it will be much more intense, like red color. This is the pH scale. So strong acid is around pH 1 to 3, weak acid is around pH 4 to 6, give or take, okay? Now, between all of these, what else can I tell you? Describe qualitatively strong and weak acids, extent of dissociation, full dissociations into H plus versus partial dissociation into H plus ion. So A, B, and C are done there. So what I'm going to do now really is to go through these characteristic reactions of acids with metals, with bases, as well as carbonates. I found out from the other class that, a lot of people still don't know their year 9 chemical formulas. So there are a couple of year 9 formula of ions that are very, very important. Can I find out from people, have you ever done something called qualitative analysis? So qualitative analysis means test for cations, test for anions, that kind of thing. So how many people have done this before? Can I ask Afika, have you done this kind of practical before? Is Afika there?
No.
Have you done this before?
No.
In the lab? No, never. Have you learned this before in school under theory? In your theory component, have you learned this before?
Yes.
Okay. Irene, how about you, Irene? Have you done this as practical before?
No.
No. Have you done this in theory before?
Yes.
Okay. Hazwani Hidayah, have you done this in theory or practical before? Or both? Sorry, I can't hear you. Are you muted?
No.
So you have not done the practical. Have you done the theory before? Hazwani, have you done the theory before? Sorry, I can't hear you at all. Have you done this in theory paper before? Have you gone through like as a theory concept before? You forget, but you have done it. Okay. And last but not least, Hazira, have you done this in practical or theory before?
I think I done it in practical.
Oh, okay. And have you done it in theory yet?
No.
Okay, all right. Now, straight from your syllabus, yeah, okay. I just want to highlight, sorry, you might get headache from this. There you go. This is qualitative analysis. So list of apparatus, practical techniques. They expect you to have done this kind of qualitative analysis. So of course, because of COVID last year and then school is coming back, I think, if I'm not mistaken, big school like MS, they might go for alternative to practical, which is paper 4. But just because you are doing alternative to practical does not mean that you can forget about doing practical. You need to think about these tests for cations and anion as well, because this table here, I'm going to show you this table, this one, qualitative analysis notes in your current syllabus, in the 2022 syllabus, this table is not given. It's not given in paper 1. It's not given in paper 2. It's not given in paper 4, even though paper 4 is alternative to practical. It's not given in your current syllabus. That means the exam that you're going to sit for at the end of this year will not have the table in your paper 4. Only in paper 3 if you are doing practical, which means you need to know the formula of these ions. In fact, these are year 9 chemical formula. You would have learned them as year 9. When you did year 9 formula of compound, you have learned a table of ions, CO3 2 minus, carbonate, Cl minus, iodide, and then you have NO3 minus. Nitrate comes from nitric acid. Do you know what is the formula for nitric acid? Anyone? Can you tell me? Can you just unmute yourself and just tell me the formula of nitric acid? Come on, just anyone. No one know the formula for nitric acid or sulfuric acid? I should probably pinpoint the person. Hazira, what do you think, Hazira? What is the formula for nitric acid?
HNO3.
HNO3 is correct. When you think about the acid gives you the anions. So when you have HNO3, it is a strong acid. When you give away the H plus, then what is get left behind will be the anion. So H plus and O3 minus. That means when you want to get back the acid, if you know the NO3 minus correctly, then you can get back the formula. 1:1 because +1 cancel -1. The formula for nitric acid is HNO3. You cannot forget the formula of your acid, yeah? How about the formula for sulfuric acid? Irene, what is the formula for sulfuric acid? Yes, Irene?
H2SO4.
H2SO4, it's either whether you know it or whether you can write, whether you can get it from here, where you have H plus and SO4 2 minus. 1 and 2, from the charges, you get the valency, and then you cross multiply to exchange the valency. This is how many. So that means you need 2 H plus and you need 1 SO4 2 minus, you get H2SO4. Of course, we know that a strong acid dissociates fully in solution. You get 2H plus and SO4 2 minus. So sulfate, SO4 2 minus. Do not just say SO4, it comes with charges according to your practical qualitative analysis, which of course, it will never be given in your theory paper. The sulfate comes from sulfuric acid. The nitrate comes from nitric acid. Chloride, salt usually come from, well, I mean, you can test the chloride from anything, but if you get chloride salt, they should have come from your acid, which is hydrochloric acid. Hopefully that makes sense there, yeah? You have a list of cations. Out of all the cations, they should be all pretty clear. Some of the difficult one include zinc 2 plus. So zinc, when they form ion, is 2 plus. Iron can be iron 2, iron 3, depending on what is the oxidation number of this thing in the Roman numeral. Ammonium ion, this is a tricky one. Ammonium ion. But if you notice what I told you before, ammonia is a weak base. Ammonia is a weak base. It dissociates partially in water. Ammonia plus water, write your equations. Partial dissociation, that means reversible. I mean, I should have written down, I should probably write it down properly like this. And then I will show reversible. And then the NH3 has a lone pair. It accepts H plus. So it becomes NH4 plus. And then I have OH minus like that. So that means I get OH minus, from ammonia dissociating in water partially, and this NH4 plus is ammonium. So you get ammonium when ammonia reacts with something. Okay, so ammonium, NH4 plus, there's 1 nitrogen, 4 hydrogen, and 1 plus 1 charge there. Test for gases, these are all the gases that you're expected in your O-level syllabus. Ammonia, almost everyone knows this term, red MS paper blue, is a test for alkaline gas. Test for alkaline gas. CO2, carbon dioxide, turns lime water milky. Each of these gas is your simple covalent molecule from your structure and bonding. I am not drawing the dot and cross. I am simply drawing the display formula where you should know carbon to 4, oxygen to 6. Oxygen share 2 electrons to complete the outer shell with the nonmetals. Carbons share 4 electrons to complete the outer shell with the other nonmetal. By drawing display formula, I can count carbon from 1, 2, 3, and 4 bonds. I can count each oxygen from 2 covalent bonds. I can count nitrogen require 3 electrons. So they will share 3 electrons to complete the outer shell. And hydrogens, being hydrogen, they just need 1 electron to be shared to complete the outer shell there. Chlorine, group 7 and group 7. So, they will just share 1 outer shell electrons, etc., etc. To draw the dot and cross, make sure that you know how to draw dot and cross. But the number one mistake is that correct? Is that correct, Africa? Ammonia. So based on this diagram, is this correct? Dot and cross for ammonia? What do you think, Africa? Correct or not?
Yes.
What do you think, Irene? Correct or not? Yes, what's wrong? Correct or not? That's the question. Correct or not?
No.
Why? What's wrong then? If you Go on.
Outer shell of nitrogen is 5 electrons.
So you only use 1, 2, and 3 for bonding. So how many are you left with?
2.
You only share 3, so you still have 2 more. It can be 2 dot or 2 cross. Whenever you draw dot and cross, one of the most important thing I think I told you before is count. This thing here is display formula. It allows you to count the number of bonds correctly and it saves you time, but it doesn't count the outer shell electrons for you. Oxygen has 6 valence electrons, 6 outer shell electrons. You use 2 for bonding, you still have 4 more. So count. Whenever you think you did something correctly already, do not lose silly marks by not counting. These are all simple skills. Count your outer shell electrons. Do not miscount them. So, that's what I'm doing. These are all tests for gases. I hope you've done all these tests for gases before, whether as a theory or whether you've done that in practical, which the easiest one would be the ammonia, the carbon dioxide, hydrogen, oxygen. Chlorine is a bit difficult to produce in the lab, but you can produce it in practical, and you can definitely bleaches. Do you know what these bleaches mean? Does anyone not know what bleaches mean? Bleaches is like what you have in Clorox, Clorox. So Clorox is what you call bleach. So a bleaching agent, what do you use Clorox for? You put Clorox into your dirty laundry and everything's become what color again? What color does it become when you put Clorox into your laundry? What color do you get, Hazira?
White.
White. So bleaches actually turn everything into white. So it doesn't matter whether you use red litmus or blue litmus, it will turn white. But we don't call it white now, okay? We call it bleach because that is present in your bleaching agent. When you use Clorox, you smell like a very overbearing, overpowering kind of smell. That's the smell of chlorine, like the smell of swimming pool, yeah? Okay? Test for gases, test for cations, test for anions. You're supposed to know this table completely. So carbonate reacts with acid to give you carbon dioxide. That is one of the key reactions that I'm going to identify here. So sorry about the headaches. I'm just going to go back to your acid and bases. There are a few characteristic reactions for acid and bases. Yeah, so I already gone through that. So these are the reactions of acids and also bases. Now, reaction of acids and bases. Acid give you salt. That is the most important thing. Acids produce salt. So whenever there's a reaction of acid with something, you always get salt, okay? So what happens in salt is the H plus from acid gets replaced by, so it gets substituted by another cation. So something else take the place of the H plus. So the name of the acid will still contain the anions because you're just replacing the H plus. You're just replacing the H plus, which means what happened is if you have HCl, if this is the acid, what is the name of the salt that you will get from HCl? What must it contain? It will contain the Cl minus because only the H plus get replaced by the other cation. So the Cl minus remains. So what is the name of something that has Cl minus? How do you name that, Africa? Something that has Cl minus. What do you name that as, Africa? Is Africa there? Yes. You name that as chloride, not chlorine. So this is your hydrochloric acid. If you see the question give you hydrochloric acid, they will give you chloride salt. How about sulfuric acid? What kind of salt does sulfuric acid give you? What is the name of the salt, Irene? Any thoughts, Irene?
Sulfate.
Yep, because the H plus get replaced by metal cation, you're left with this SO42 minus, which was in your test for anion, which means you're supposed to know them. How about this nitric acid, which came from HNO3? So after the H plus get replaced by the metal cations, what are you left with, Hazwani Hidayah? What is the name of the salt? Hazwani? 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 Nope, it's okay. Afrika, what do you think?
Nitrate.
Nitrate, because you are just left behind with NO3 minus, not NO3, NO3 minus, as stated in the syllabus just now under the practical test for cations and anions. Okay, last but not least, I haven't really mentioned this, but remember there was ethanoic acid. So etanoic acid is in this topic called carboxylic acid, but you also learn it in your acid and bases topic. If you draw carbon form 4 bond, I'm just drawing the display formula. You will see the hydrogen form single covalent bonds, and then the oxygen form double covalent bonds, which of course you can draw the dot and cross from this diagram, I hope. And you know how to complete your outer shell. Okay, so Irene knows how. I'm not sure about the rest of you. Okay, count your outer shell electrons, yeah? So remember what happened just now when I showed the dissociations. The CH3CO2H partially dissociates into CH3CO2 minus plus H plus, because you dissociate into the H plus partially, you are a weak acid. But after you dissociate into the H plus, so the H plus get replaced by another cation, by another positive charge ion. Then you're left behind with CH3CO2 minus. The question is, what is the name of this CH3CO2 minus? How do you name it? From the name etanoic acid, what is going to be the name of the N ion? Do you know this, Hazira?
Yes.
What is the name then?
Etanoic.
Etanoic is correct. I'm not sure about the rest of you. So if you don't know how, have a look at the name. It's oic acid. The acid contains the H plus. Take away the H plus, so no more acid. It's now O8. 8, 8, 8. It contains oxygen. This doesn't contain oxygen. It's just chloride on its own. That's why it's not 8. Okay? So be very careful there. This is etanoic ion. I could have gone further. If I give you, I don't know, you might not have done butanoic acid, but if I have CH3, CH2, CH2, CO2H, altogether I have 1, 2, 3, and 4, including the CO2H, I have 4 carbons. 4 carbon carboxylic acid is called butanoic acid. Butanoic acid. So what is the name of the salt that I will get then? What do you think, Irene? What is the name of the salt that I will get?
Butanoate.
Butanoate is going to be correct, okay? Sorry, Hazwani, I just saw your text, okay? Maybe your mic wasn't working very well, but it's okay. As long as you can hear me, it's fine. And make sure you do take some notes along the way as well, rather than, just listening, which you will not get any better. Having done all that, we are ready to go for the reactions, okay? So I'm going to write some key word equation first. Word equation are less likely going to come out in your O-level. Most likely it's like chemical equation. But as with any reactions, you need to learn how to write the word equation first. So in reaction 1, doesn't matter which one you want to write first, I guess. 1 or 2 or 3 first, doesn't matter. Metal plus acid. When acid reacts, acid will give you salt, always. If acid reacts with something, it will give you salt. Salt means the H plus reacts, the H plus is replaced by another metal cation. So that means here it must be metal salt. This reaction produces a gas. What is this gas that is produced? What do you think, Irene? What gas is produced here, Irene?
Hydrogen.
Hydrogen gas. Okay. What is the test for hydrogen gas, Irene? What do you use? Hydrogen gas. What happened then? What can confirm that it is hydrogen gas? What happened to it?
Pop sound.
Okay, it burns with a pop sound. Don't just say pop sound, okay? You use lighter splint. The lighter splint burn with a pop sound, okay? Have you done this practical before, Irene?
Yes.
Okay, so I hope all of you have heard the pop sound before. Very obvious, yeah? Okay, so what happened then is, if I use zinc, if I use hydrochloric acid, so what is the name of the metal salt that I will get? What do you think, Africa? What's the name of the metal salt? Zinc plus hydrochloric acid. Yes, Africa? So look at the acid first, and therefore think about the salt that you're going to get. You replace the H plus with the metal, right? So what is the name of the salt? Forget already? This is HCl. Replace the H plus with the metal. So you're going to get Cl minus. What is the name of Cl minus salt?
Zinc chloride.
Yep, so it must be chloride from the acid, and then the metal is just zinc, okay? Now you also produce hydrogen gas. The question now really is, we have to write a balanced chemical equation. Whatever equation you write have to be balanced. So let's try and write a balanced equation. Zinc is Zn. It is a metal, so it has giant metallic structure. It has metallic structure, yeah, giant metallic structure. HCl, hydrochloric acid. What is the formula for zinc chloride? So to get the formula of compound, you must know the formula of the metal cations and the non-metal anions. So what is the cations and what is the anions? Hazira, what is the cations? You're supposed to know the formula of zinc cation, Hazira. But the rest of you should know as well. What do you think, Hazira? What's the formula for zinc cation? You're not allowed to look at that table because that table is not given to you in exam. So, what is the formula for zinc cation?
Zn2 plus.
What is the formula for chloride ion?
Cl minus.
What is the formula for zinc chloride?
ZnCl2.
That is correct. For the rest of you who don't know how to do it, we look at the charges. If we can get the formula of the ions correctly, we can get what is called the combining power. This is not valence electron, it's just the valence is called the combining power. Look at the charges of the ions. When you do crisscross, you get 1 and 2. This is how many of the ions you need in order to balance out the charges there. And then the formula for hydrogen is H2, diatomic molecule H2, with no other outer shell electrons because the first shell can only have 2 electrons in the outer shell. If you write this equation, you will get 0 straight away. Any equation you write, even though the question doesn't ask you to balance, any equation you write, if the question doesn't ask you to balance, you also have to balance. It's a standard that is required by Cambridge. Okay. Now let's try another one. I'm not sure, yeah. Hazwan, your mic might not be working, but try to unmute yourself and see whether you can answer this question or not. Magnesium plus nitric acid. Magnesium plus nitric acid. Let's just use word first. Let's just use the word first. Magnesium plus nitric acid. We pronounce them first. What is the name of the salt, Hazwani? Magnesium plus nitric acid. Yes?
Magnesium nitrate.
Magnesium nitrate is correct. Now, Hazwani, continue. What is the charge on magnesium ions? This is magnesium metal. When they form salt, there will be cation. It is plus how many? Where is magnesium in the periodic? It's 2 plus because it's a group 2 metal in the periodic table. Now, nitrate ions. What is the formula for nitrate ion, Hazwani? Nitrate ion, Hazwani. I can't hear you now. Can you speak up? I think she's this.
Yes.
Okay, I can't hear you very clearly, but I think it's the NO3 minus. So I'm going to ask Irene to continue. What's the formula for magnesium nitrate then?
MgNO3 in bracket 2.
Okay, so usually we pronounce it as Mg bracket NO3 twice. Okay, the international standard of pronunciation is Mg bracket NO3 twice. Okay, the NO3 is treated as a unit, but we mentioned the bracket before we say Mg NO3 bracket twice. We said Mg bracket NO3 twice. Okay, now you also produce hydrogen gas. This equation is not balanced. When you balance these kind of equations, I think I told you before, do not try and balance the oxygen individually. Look at the whole unit. I did say that we need to think about NO3 minus rather than NO3, but when you're balancing equations, you need to think more about the whole unit. NO3 unit. I don't say NO3 minus, I say NO3 unit, so that it's easier to look at NO3 unit. I have 2 of NO3 unit. I only have 1 of NO3 units. I cannot change the number here because it's H plus NO3 minus, but I can change the number in front to become 2. Now I have 2 hydrogens, 2 hydrogen, 1 Mg and 1 Mg. Okay. Now this is a metal and acid reaction. Every single metal and acid reaction, you can see the metal as an element. And then you can see the metal as the cations. So what has happened from the metal element to the metal cation? What has happened there? Has it gained electron or has it lost electron? What do you think, Afika? From the metal element on the left to the metal cation on the right, has it gained electron or has it lost electron?
Loss.
So the metal element has lost electron. The metal element has lost electron. Okay. So if you have lost electron, is that oxidation or reduction? What do you think? Who did I ask just now? Africa, right? Continue. Loss of electron, is that oxidation or reduction?
Oxidation.
Okay, so we know about oil rig, as I did a whole bunch of electrolysis topic with you. Oil rig, oxidation is loss of electrons. So if that is your oxidation, what is your reduction then? You need to figure it out. Every single acid contains H+. This is H2. So what happened is you can think about H+ becoming H2. You need to gain electrons because no charge there. Plus charge must gain electrons. And this is your classic electrolysis equation. When you produce hydrogen gas, you need 2 and 2. So this is your reductions. Reduction is gain of electrons. We gain electron on the left. And what happened with the metal is, example, you have zinc going to zinc 2+ plus 2 electrons, or Mg going to Mg2+ plus electrons. But of course, you could also have Na going to Na plus electrons when you have a group 1 metal. Okay, so this is your oxidation. Oxidation is your loss of electrons. So by doing or by showing these two, then you can say this is a redox reaction because there is a gaining and losing electron. There's oxidation and reductions. Okay, I hope everyone is okay. Yeah. So metal plus acid is always metal, salt, and hydrogen gas. It is a redox reaction. There are many things they can ask you here. There are some more questions they can ask you here. Between zinc and magnesium, which one will be more reactive, zinc or magnesium? Which one is a more reactive metal, Hazira? Have you done reactivity of metal, Hazira?
Yes.
So which one is more reactive, magnesium or zinc?
Magnesium.
So what will be the difference? What would you see? So in this reaction, what do you see in this reaction, Hazira? What do you observe? As I put magnesium into nitric acid, what do you observe? The rest of you try as well, yeah? What do you observe, Hazira? What do you see? They like to ask this kind of question, right? So what do you see? Go on.
Magnesium displaces hydrogen.
But is that what you see? I mean, when you're doing an experiment, you see something, right? So this is an acid, it's a solution. Magnesium is a solid. I put the solid into here. What will I see in this reaction? It's quite obvious. So it produces a gas. So what do you see when the reaction produces a gas? What do you see? You are thinking too much on theory. You need to think about, if you are doing this in the lab, if you produce a gas, what actually tells you there is a gas in the first place? What tells you there is a gas? Any idea? Anyone else want to chip in? I don't know. Irene, Africa, I don't know. Anyone else? What do you see when you produce a gas? If a reaction,
Bubbles.
you see bubbles. So this is something that you have to learn, okay? If you produce a gas, you will see bubbles. That's why you can monitor these reactions by looking at the rate of bubbling. So you see bubbles, you will see effervescence. As the metal reacts, what do you think happened to the size of the metal? Would it get bigger or will it get smaller? Anyone? So the metal will react to the acid. Will the metal get bigger in size or smaller in size? Huh? No one knows? What do you think, Hazwani? Bigger or smaller? As the metal reacts to the acid and give you the salt, and then you will see bubbles already, what happened to the metal? Will they get bigger or will they get smaller in size? Do you get more metal or do you get less metal? That's the question. Are you there, Hazwani? Hello, hello. Do you get more? Do you get more of the metal or less of the metal? As it undergo reactions, it will get used up, right? So do you get more of the metal or less of the metal? Less. So your size will get smaller. If you have excess acid, then all the metal will disappear because all of them were reacted. If the metal is in excess, then you know the reaction is complete when there are no more bubbles. But you will have some solid remaining if the metal is in excess. Okay. Now, what else could they ask you? They could ask you to collect gas. Do you know something about gas collection? What apparatus do you use to collect the gas? If you want to collect the hydrogen gas, what apparatus do you use to collect hydrogen gas? Let me ask, I don't know. Afika, what apparatus do you use to collect gas?
Gas syringe.
You can use a gas syringe. There is actually another method, or you can collect over water. This is a downward displacement. This is in a measuring cylinder. I'm not sure if you have seen this second one, but it came out in a practical exam during the COVID year. I think it was June 2021, paper 3. Okay, it's quite a scary question. It's never come up before, but if it comes out again, you should make sure that you know how to do it. So what happened in a gas syringe is, I would have a collection like this. Make sure you know how to draw. In paper 4, alternative to practical, they usually like to ask you to draw the apparatus setup. So this is a gas syringe. A gas syringe looks like a syringe they use, in the hospital or whatnot. So it has got these lines that allow you to read the volume of the gas syringe. So you will have this piston push all the way, and then as you produce the gas will push out, and then it will allow you to read the reading. So this is a gas syringe, and then inside there is your solution mixture. And of course, you need to seal it up so that your gas doesn't escape. Now, there's another alternative method. This is the collection of the water. So this is the one which I mentioned. So again, you need to seal it up. And what happened there is this will collect over water. So it's like a downward displacement. Your measuring cylinder is inverted. Inverted meaning the other way around. So, if you are inverted, you need to fill it up to the max, and then you invert it completely into there so that the water doesn't come down. And then as the gas gets produced, what happened then is this water will get displaced. And this is your measuring cylinder, and you can collect the volume of gas inside there. And you will be able to, like if the volume of water comes down, then from there to there, you are reading upside down. This is the volume of gas that are being collected there. Hopefully that makes sense there. Of course, you need to have your solution mixture there. So gas collection apparatus, yeah. This is about rate of reaction. Just now, my question for you guys was about reactivity of metal. Reactivity series, you learn about it in electrolysis, Carboxylic. So this is just the way we, think about the acronym, and you have copper, silver, gold, and then carbon. Carbon comes in between aluminum and zinc, somewhere there. Hydrogen comes in between just after lead, just before copper. So these are all your reactive metal. Magnesium is more reactive than zinc. So magnesium will give you a more rapid bubbling. So magnesium will be more rapid bubbling, more rapid effervescence than zinc, because it is a more reactive metal. So hopefully that makes sense to you, yeah? Many things you can do in this kind of thing. If you are collecting the gas, if you have your stopwatch, you will have collected more gas in 10 seconds or in 5 seconds compared to with zinc, because your reaction is faster, so you will collect more gas in the same time. But anyway, I want to focus more on the reactions now. Metal plus acid give you metal, salt, and hydrogen. Of course, if you are below acid, if you are below hydrogen, copper, silver, and gold does not react with dilute acid, but it can react with concentrated acid if you want to. Now, these are the first general reactions. So onto the second general reactions, what you have is acid plus metal carbonate. Now, just now, you have the test for carbonate. I hope you remember that in your qualitative analysis, carbonate CO3 2 minus, you add any dilute acid, doesn't matter, any acid you get, and then this is what you will see. You will get effervescence. Effervescence means a lot of bubbles. I should probably spell this properly. EFFERVESCENCE. You don't like that word, you can use rapid bubbling. It's not just bubble, it's rapid, very, very, very fast. Okay, test for gas. If you want to test for this gas, you have to test for CO2. And what is the test for CO2 again? Let me ask, I don't know, Hazwani, are you there? What is the test for CO2? Yes, Haswani, what is the test for CO2 gas? Can't hear you at all. Okay, never mind. Let me ask Irene then. Irene, what is the test for CO2 gas?
Lime water.
Okay, you use lime water, but don't forget, when you use a test, you also have to specify the result. What is the result?
Milky white.
So it turns milky, or it turns white, or it turns cloudy. So whichever one you like to use, okay? So what is present in the lime water? What is lime water actually, Irene? What is this reaction that turned it milky? Do you know?
No.
You don't know. Lime water is calcium hydroxide. Lime water is calcium hydroxide. And guess what? CO2, I haven't mentioned this today, but this is acidic oxide. You have an alkaline because it has hydroxide or its base. So acid plus base is actually your third reactions. So acid plus base, what do you get? You get salt. So you get calcium carbonate because the salt that comes from CO2 is carbonate salt. CO3 2 minus combined with group 2 cation, Ca2 plus, and then you get water. And this equation is balanced. Ca, CO2, take away one oxygen from there, CaCO3, and you have lost one oxygen, you're left with H2O. Okay, guess what? Have you learned solubility rules, Irene? Solubility rules? Okay, have you done salt preparation at all? Have you done this topic called salt preparation? Have you done acid and bases topic?
Yes.
Describe the general rules of solubility. 2022 syllabus, 2022 syllabus. So if you have done acid and bases topic, you have done preparation of salts, where you need to know the general rules of solubility. These are a set of rules, make sure you know all of them. What I'm going to talk about specifically is your rules on carbonates. So all carbonates are insoluble. So all carbonates are insoluble, except, now this is quite unusual, Na plus, the carbonate containing Na plus, K plus, or NH4 plus carbonates. These three are going to be soluble because all the group 1 cations and ammonium salts, Na plus, K plus, all the group 1 cations and NH4 plus salts are going to be soluble in water. So every other carbonate is insoluble. You are producing calcium carbonate. You are producing calcium carbonate as you test for carbonate ions. So obviously this thing is going to be insoluble white precipitate, which is your cloudy precipitate there. Okay, hopefully that makes sense. By the way, test for CO3 2 minus stated in the syllabus there. Okay, so I have digressed a little bit. So acid plus metal carbonate, this will give you metal salt because acid reaction will give you salt. You get carbon dioxide gas, which is CO2, and you also get water. So any acid plus any carbonate will give you salt, carbon dioxide, and water. Which means if we come back to general equations, example, if I have zinc carbonate plus, I don't know, let me change the another one, sodium carbonate plus sulfuric acid. This is a metal carbonate plus acid. What will be my product, Afika? Afika, what will be my product? Sodium carbonate plus sulfuric acid. I can't hear you at all. You didn't say anything. So the sulfuric acid will give you a salt. You replace the H plus with the metal cation salt. What do you get, Afika?
Sodium.
So H2SO4, you replace the H plus, 2 of them, and now you're left with SO4 2 minus. What is the name for SO4 2 minus?
Sodium sulfate.
So you need to know this kind of thing. Yeah, you have to think about it. Yeah, okay. And then what else do you get? This is a metal carbonate plus acid. What else do you get? Yeah.
Carbon dioxide.
Yep, because test for carbonate, any carbonate reacts with any acid, give you carbon dioxide, and you get water. Now the formula, sodium carbonate, the formula. Come on very quickly. Irene, what is the formula for sodium carbonate? If you know your formula of ions, you'll be fine. What formula is the sodium ions, Irene?
NaCO.
Okay, give me the formula for sodium ion first. Sodium ion, what's the formula?
Na+.
Okay, carbonate, what is the formula for carbonate ions? Remember just now, I told you it was in the practical, right? So what's the formula for carbonate ions? You forgot. You forgot. You hesitated. That means you forgot. CO32 minus, okay? CO32 minus. So the correct formula for sodium carbonate, what is it, Irene?
Na2CO3.
Sulfuric acid, go on. Yes, Irene?
H2SO4. H2SO4.
Okay, I mean, it was just given on top here. Okay, and then sodium sulfate, what is going to be the formula? So you have sodium ions, and then what is the formula for sodium sulfate? Yep, go on. Don't wait for me. Sulfuric acid is like this. You replace the H plus with the metal. H plus replaced with Na plus. I wonder what's the formula for sodium sulfate. No? Yes, Irene?
Na2SO4.
Yeah, because you replace the 2H plus with Na plus, they have the same charge. If you want, you can go back to your basics, everyone. This is your valency. Based on the charges of the ions correctly, sulfate SO4 minus, the valency is 2. Na plus, your valency is 1. So 2 and 1. So this means you have 2 of these ions on the left and 1 of these ions on the right. Lowest common multiple says that your objective is to balance out the charges. +1 + 1 is +2. Cancel out -2. Na2SO4. You get CO2, get H2O. You have 1 sulfate unit, 1 SO4, 1 SO4. 2 sodium, so I need 2 sodium, which I already have 2 sodium. 1 CO32 minus, give you 1 CO2, because the carbon dioxide comes from carbonate as it reacts with acid. So if you have 1 CO2, that means you have 1 CO32 minus. This equation is balanced on its own like that. The tricky thing really is whenever you write equations, get to the correct product with the correct formula, check its balance, check that it's balanced. If it is not balanced and you're sure your product is correct, most likely your formula is wrong. So you have to start off by knowing the correct formula, well, by being able to get to the correct formula, okay? Being able to get to the correct formula. The third general reactions is what you call neutralization. Neutralization is this between an acid and a base or an alkaline, and then acid reacts to give you salt. But neutralization, pH below 7, pH above 7, give you pH 7, it's just salt and water. Neutralization reactions is quite nice in the sense that you have aqueous and aqueous ions, H plus and OH minus, and then you will just get H2O liquid. And then you should know neutralization is exothermic, because here you are not breaking any bonds at all. In fact, you are just forming bonds. If I just show you, this is OH like this, but now you have formed a new bond. This is just your H plus. You don't break any bond, they just come together and they form a new bond. Bond forming or bond making or bond forming is what you call an exothermic reaction. That means it will release heat energy to the surrounding. So if you release heat to the surrounding solution, so what happens to your solution is your temperature of the surrounding will get hotter because it releases heat to the surrounding. We have the thermometer outside in the solution, it will get hotter. It will increase in temperature, characteristic of exothermic reactions. This is what you call ionic equations. Someone did ask me just now, do you need stat symbols in your equations? You don't need to unless it's specified in the questions. But when they ask for ionic equation means we don't show the ions that are not important. Ionic equation for neutralization, if we can identify acid and base, guaranteed this is the only ionic equation. Every single acid and base comes down to this. Example, HCl plus NaOH. This will give you NaCl plus H2O. Example, H2SO4 plus NaOH. What do you get here as your product? What do you think you get here as your product, Africa? What is your product? H2SO4 plus NaOH, Africa. So acid gives you salt. Salt is when the H plus get replaced by another cation. So what do you get?
NaSO4 plus H2O.
You have made a mistake. Na plus is your cations. SO4 2 minus. You got 2H plus sulfate according to the test for anion. SO4 2 minus. Irene just did this around 5 minutes ago, and you already forget about that. You don't learn by watching only, you learn by doing. Here, you do need to balance the equation. You have 2 Na, so you need 2 NaOH. But here, you also need to balance the water because 2 OH minus, 2 H plus, 2 H2O. But then guess what? 2 H plus, 2 OH minus, 2 water comes down to the same ionic equations. Doesn't matter what acid you use, doesn't matter what base you use. Neutralization produces salt and water. The same ionic equation goes for any acid plus base reactions. Okay, hope that is all right for everyone. Now, this next one is the tricky bit. You have learned from topic 1, diffusion, yeah? HCl plus NH3. What is the name of the product? This is ammonia, and then what you have is hydrochloric acid. So what is the name of the product? Acid plus base will give you salt. Acid plus base will give you salt. So the acid is hydrochloric acid. What is the name of the salt? Irene. Yes, Irene, what is the name of the salt? Hello? Hello,
Not
Irene?
sure.
Okay, well, try. Hydrochloric acid. The H plus get replaced by another cation. So what does it contain? It contains Cl minus, agree? So what is the name of Cl minus salt?
All right.
Okay, so you know acid gives you salt, okay? Now, what does ammonia do? Ammonia has a lone pair, a base here, this acid donates proton. Acid donate H plus, base accepts the H plus. Okay, so NH3 accept H plus, NH3 plus H plus, what do you get? You still have 1 nitrogen, 3 hydrogen plus another hydrogen give you 4 hydrogens, but no charge and plus 1 charge give you a plus charge. What is NH4 plus? It's a cation. The cations is NH4 plus. Another cation has replaced the H plus when you form a salt. The H plus in the acid get replaced by a cation. What is the name of NH4 plus, Eric?
Ammonium.
Ammonium, no longer ammonia. So this is called ammonium chloride. And then the way you write NH4Cl is without the charge because 1 and 1. So the charge cancel out. I'll just show you one last equation. Okay, this is just with when you have ammonia. So example, when you have sulfuric acid. So this is sulfuric acid, which is H2SO4. Now you react it with ammonia, which is your base. Okay, so this is your acid. This is your base. So the acid gives you the salt. What is the name of the salt that comes from sulfuric acid, Africa? What is the name of the salt that comes from sulfuric acid, Africa?
Sulfate.
Sulfate. So ammonium. Salah, give it away already. When ammonia forms salt, ammonia will form ammonium salt. So it's ammonium sulfate. Okay? Because the base will take away the H plus from the acid. The salt is ammonium sulfate. What is the formula for ammonium sulfate? This is one of the tricky one. What is the formula for ammonium ion again? Irene, ammonium ion.
NH4.
That is wrong. NH4 plus. Ion has a charge. Okay. What is the formula for sulfate ions, Africa? Sulfate ions.
SO4 2 minus.
That is correct. Now 1 and 2, your job is to cancel out the charges. This is valence C from the charges. How many of the ions you need is what happens when you do the lowest common multiple or when you do cross multiply of the charges. So the formula is going to be 2 of the ammonium ions and 1 of the sulfate, ammonium sulfate. They'd like to ask you the percentage content of nitrogen. That was from year 9 mole calculation. Make sure you can do the MR. Make sure you can do 2 times 14 divided by the MR times 100%. Every equation you write must be balanced. 2 ammonium, that means come from 2 ammonia. 1 sulfate, 1 sulfate. The 2 extra hydrogen, this equation is balanced now. If you try to balance this with water, you won't be able to balance it. Okay. There is one equation which I haven't shown you. It was something I covered with the other classes just now. So if you had time, go through the last 5 minutes of what I covered in the session 1, which I'll upload the video eventually. And it was basically about this explanation on ammonium salt. Anything that contains ammonium ions, you test for it by adding anything that contains hydroxide, you get salt, ammonia, and water. That was in the last 5 minutes. I think people who joined this session a bit early, you saw me going through these just now towards the end of the first session. So do go through that when you have time. And that basically sums up the reactivity of acids and bases. Haven't had time to go through acidic, basic, or amphoteric oxides, but we can continue that next time. Okay, so you guys take care. So I'll see you guys next time. Yeah. So the PDF will be online in the Google Classroom soon, 5 minutes from now. But the video probably won't be uploaded until tomorrow. Okay, so everyone take care, and I'll see you guys in person very soon. Okay, thank you. Bye-bye.
Thank you, sir.
Thank you, sir.